Greetings! So in my previous video I pulled this soldering iron out of the box. Now it's time to do something with it. So I purchased a kit. There it is. It's a kit. This particular kit is an oscilloscope. So let's pull it out of the box. First thing to note, this isn't even remotely anti-static packaging. Mind you, in the interest of full disclosure, neither is this. So I'm going to go ahead and let that slide. So let's pull it out, see what we got. We have directions. The listing said the directions were very good. Yep, those are directions. Interesting, they're using the same picture for the transistors as they are the regulators. And oh, look at that. There's even a nice little troubleshooting guide at the bottom. How handy. All right. Second sheet of directions are a schematic that one figures would match the board I have, and the actual directions on how to make it work once it's fully assembled. So let's start looking at stuff. First thing I'll look at is the PC board. There are two versions of this kit. One version had the surface mount parts already loaded, one version did not. Interestingly enough, the version with the surface mount parts loaded was slightly cheaper. So yeah, figure that one out. Everything seems to be nicely marked. I will say the microprocessor there would be a little tricky to do without the use of a microscope or some sort of a magnifying device. But all this through-hole stuff should be pretty easy to do without. So actually before I go on, these resistors here that I doubt anyone will can actually pick up on the camera are actually quite large compared to what I work with at work. So, flip it back over to the back side of the board. Looks like they do have some places for some assorted jumpers. One thing to note, that's the date code there. It's not going to come up on the camera. I'll tell you it is 1615. So it's either the 15th week of 2016 or the 16th week of 2015, depending on what standard they're using to put the date code in. And then there's this other number up there. What is missing, I would personally expect above that number would be a marking that said UL94V0. 94V0 is the flammability rating used on circuit boards that basically says the board won't continue burning once it starts on fire. This board, I do not see a UL mark on this board. I've not gone to the UL's webpage. This other number could well be a UL marking, and they just didn't bother putting the UL 94V0 mark on the board. So that's the board. It already has surface mount parts on it. Comes with a set of alligator clip test leads. This kit uses a BNC connector for the oscilloscope probe, so I would hope you could use standard oscilloscope leads. This is the LCD screen for the oscilloscope. Pull this out. Little LCD screen, 2.4 inches, according to the silk screen on the board. So we'll see how well that looks once it's assembled. Now, here comes the fun part. Those are all the piece parts. All the passives, all the through-hole parts. So this will be a mess. Stand by for a jump cut while I organize these parts into more meaningful piles. Alright, so here's the parts all arranged, or at least sorted out into different groups. Resistors, capacitors, the inductors, and basically everything else. The downside of this kit is all of the parts are shoved in a bag, and there are several different resistor part numbers. So this is the boring part, where I go be lazy, get up my multimeter, and measure resistors, stuff them in the holes. So, unfortunately, the color of the way these resistors are colored, it's hard to differentiate the color bands on them. The blue background they use isn't kind of masks the what the value ought to be. So this is a 1K resistor. I'm just making sure there aren't any resistor values that are close. So, okay, 1K. In fact, I'm going to do another jump cut while I run and grab a pencil. And I'm back. All right, so as I stuff parts in the board, I will be marking off the reference designator to make sure I, get everything. Make sure I'm not missing parts. One very nice thing the people who designed this board could have done and didn't was, once they got all of the parts laid out, they could have done a renumbering sweep. Start in the top corner, go across and down, and renumber the parts so the lowest reference designator's up here, the highest one's down there. They didn't do that, so we get to hunt for parts. First one I'm looking for is called R9. All right, there it is. It was hiding. So stick the parts in, or stick the leads in, fold them over. All right. Next randomly grabbed resistor is 180 ohms. I do have a 180. So here's what we're going to do. A handy trick if you ever wondered how to form resistors without the proper equipment. You grab the resistor by the body and just fold the leads over. You'll get a reasonably well formed resistor. So let's see here. I think I found that one already. Yes, I did. So go stick that there, stick this here, seat it down so the part's flat. And voila. So we'll just keep trudging on through. Okay, so I was left with a few straggling resistors. I couldn't quite get the resistance measured correctly. And this is how, so I've been measuring my resistance like this. You know, just holding it on the resistors. This particular resistor is measuring 79K roughly. So I have nothing around 80K on my BOM. So I broke out a cheat sheet. Say, instead of trying to remember these random dirty limerick used to memorize resistor color codes and then writing it down, it's an app I've been using for quite some time. So I deduced, or my best guess was the resistor color code on this resistor was brown, black, black, orange, which is 100K. So 100K ohm. And I looked in my BOM over here, and I do need 100K ohm resistors. So I thought, well, why isn't it measuring? Then I remembered it's actually kind of warm in the room I'm sitting in, so I'm a little sweaty. So I'm actually fairly conductive right now. My meter is saying I have a resistance of 700K, which is alarmingly low. So if I set the resistor on my table here and measure it, then it measures right at a little over 100K. So that's definitely a 100K resistor. Let me stuff this in the board before I forget what I'm doing. And the next one, since I've realized my hands are a little sweaty and a bit more conductive, we'll see. 100K. Good. I was missing all of those. So there's another 100K in here. In fact, this particular resistor, it won't come out on the camera, of course, but the color bands aren't even all the way around the resistor. Okay, next. This one's got a yellow on it, so it's definitely a different value. 2 meg. Oh, look at that, I'm missing a 2 meg. 200K. I'm missing a 200K. My last 100K. I'll just take a cursory glance around the board, see if I have any blatantly missing resistors. I neglected to mark a few off on my sheet, but I'm guessing I just forgot to mark them off. Yes, that's what it appears. So, clear all of this away. So now, I have to clean this mess up. And this is where we get to make a mess and shoot leads all over the room, knock soldering irons off the table. Find out my electronic side cutter isn't very good for electronics. At this point, there's really no rhyme or reason to the order in cutting these in. Just the overall goal at this point is to make sure, once I've trimmed the leads, they will not short out against neighboring conductors. And it does appear this board has a voltage plane flooded on the solder side here. So I will be extra careful not to make sure my leads aren't digging into the copper beneath the solder mask. The solder mask being this nice red covering that keeps the whole board from being one giant solder bridge. The remarkable thing, these side cutters must have been magnetized new, because I have hardly used them, and they've been sitting in a toolbox for the last 10 years. So I remember right, these I bought these at Radio Shack. Oh, probably in 2003, 2004. Must say, they're not very good. It's probably why they've been living in a toolbox the last 10 years. seen a review or two for cheap side cutters on the internet. And what this particular guy discovered, it's just a general rule when buying cheap electronics equipment from China, is if it's something they would use in China, chances are it's actually going to be a reasonably decent piece of equipment. His example was obviously a side cutter. He had picked up several Chinese-made knockoff side cutters. One was particularly blatant. It was a knockoff of a quite expensive US brand of side cutter. But what he decided is, if you need a cheap side cutter and you're not worried about perfect lead trimmings or perfect cuts, yeah, you'll do just fine buying a quite cheap side cutter. And the best part is, when you break it doing something silly, you won't feel too bad about it. You're not going to be out $20. You'll be out, $5. Working in electronics manufacturing off and on for as long as I have, one thing you always run into is the never-ending battle on hand tools. Do you buy nice hand tools that'll, do you buy the nice expensive hand tools that might last a little longer, or you just buy cheap ones, or do you buy hand tools that are so cheap when they break, you don't care? Fortunately, I've never had to make that particular decision. As a user of the hand tools, I would much rather they buy the nice ones because they do work a little better. But that's okay. So, now we get to the fun part. We turn on the iron. And once it gets up to temperature, I will start soldering. When I was testing my iron in the last video, I noticed the solder wasn't flowing very well. It's a kind of an odd sensation to try to describe. There's a certain feel the solder should have when it melts on your tip. And at the initial, when it was initially set at 350 degrees C, which should be plenty to melt lead-free solder. Unfortunately, it just didn't quite it didn't feel right. And this is a bit thicker soldering wire than I would normally use, but, well, it's what was easily available on Amazon when I bought it. And it happened to be made in the US, if I remember correctly. Yes, product of USA. Manufactured by a Canadian company. It's a neat trick. So, I'll show you, or I will try to demonstrate how to do this. So, I've been soldering since, for quite a long time. There we go, fix the focus. I started working in an electronics factory in 2003. I was a college student. The company I worked for had a rotation for the college students. They started out doing hand assembly, what you've been watching me do the last while. then we were moved along to a testing area where we'd go test product after it was assembled to see if it worked. And after a length of time, we moved on to customer service. We'd fixed field returns. And ultimately, the end of the program is when you were moved to engineering. So I was moved to engineering in 2005. So I was about 2 years before I was moved to engineering. And so from 2005 until January of 2016, I really hadn't soldered at all. But I'm happy to report it's just like riding a bike. I'm a certified IPC specialist in the IPC 610, which is the acceptability for electronic assemblies, and then the IPC's J standard -1, which is specifically focusing on soldering. The J standard training I went through had a skills portion where you had to demonstrate your ability to do this stuff. And I scored a 98% on through hole and 100% on surface mount. So, and that would have been after 2-3 months of practice, basically. So, I will try to show what's going on. The camera angles are a little awkward, but it's very simple. Apply heat. Add solder, and you get a rather ugly looking solder joint. One thing to note, the wire I'm using is way too big for this, so this will be an unexpected challenge. That's all right. So I'll just trudge on off camera and ramble until everyone gets bored. Who knows? I might even cut this out completely. It's the marvels of using video editing software. Come on. Come on. I will mention, this isn't my favorite style of soldering iron tip either, but it's the one the iron came with. So all I'm doing here is I'm going around until I find all the resistors. One observation, the handle for this iron is very oddly weighted. I think it would get a little fatiguing after a while. For soldering passive components, you really don't have to worry about heat. I mean, you want to minimize the amount of time you've got the iron on the parts, regardless of what sort of part it is, but for passive components, resistors, capacitors, they're quite beefy parts. Oh, got it in there. Making icicles. Guess what? This solder doesn't have quite enough flux in it. Alright, I may have skipped ahead a little bit, but I do have a couple of pieces of information to dole out before I continue. So I've continued on, have more parts on the board, everything sounds like it's soldered. Alright, first I'm going to talk about capacitors. Now, these big juicy guys here. Okay, so these big juicy caps here, these are the electrolytic caps. There'll be a number printed on them. This particular one is a 100 microfarad at 16 volts. Well, looks like they made that easy. All of the electrolytics are the same. And they're not needed till later anyway. Alright, so these little disc capacitors, they should have a value printed on them. Like this one here says 104. This one says 22. This one has 104. We're going to be seeing a lot of 104s, if I recall correctly. Yes, it's... So, the first... Yeah, so the numbering standard they're using, the first one, the first two numbers are the value of the cap. So in this case it's 1, 0. And then 4 is the number of zeros. So 1 0 and 4 zeros. Well, that's 5 zeros total, but it's a capacitor, so they work backwards, the numbering scheme. So it's actually 0.1. So this ends up being a 0.1 microfarad capacitor. Okay, that one's got a 1. 3, 3, 1. 1, 2, 1. I'm not quite as good with cap markings as I am with resistors. The surface mount resistors use the same numbering scheme. So they're a little easier to figure out. Alright, that's all my caps sorted out. And I think it's time for another jump cut. Okay, so I figured out the capacitor values. This little guy here marked 331 is 330 picofarad. The one marked 3 would be 3 picofarad. The one marked 1 is 1 picofarad. The 2 marked 121 is 12, where'd it go? 120 picofarad. My apologies. And these last two are marked 22, and they would be 22 picofarad. Then this big mess over here is all the 0.1 mic. So, this is a bit of a rinse and repeat sort of deal. So, I will jump cut until I'm finished. Next up on the list is the LED. There's the LED right there. One thing to note, the LEDs are, when you get LEDs loose like this, they're going to have a long leg and a short leg. These directions say the long lead needs to go into the square pad. Okay, well, I've skipped ahead a fair bit. Went ahead and got that on the switches. This BNC connector was a real pain to solder. Big metal thing. These two pins are directly attached to the big metal part, and the way the pins were, or the way the holes were designed in the circuit board, it felt like they were intending this to be a press fit connector. So, the sort of deal where you just push the connector in the board and you don't have to solder it. But the directions clearly said to solder it, so I tried. They're horrible solder joints, but I'm going on the hopefully it really is press fit and they don't know what they're talking about. All right, we're almost out of parts. We have one more part to solder, and it's this, and that goes into the LCD. This part will be a pain to solder. I can already see that. Okay. All right, just making sure the jack is flat before I continue. Verify. Okay. Now I've got some rather ugly solder joints here, and I turned the temperature up in my iron, and the iron seems to be working a little better. So I'm going to go back and try to clean some of these joints up. The soldering iron I use at work has a feature where it automatically sets the tip temperature by what tip you put in the iron. Or probably rather the way those irons work. I'm sure it's just a different all of the solder tips for that series of iron are have a color band on them, so I'm sure it's just a different heating element depending on the color band. But the nice thing is you don't have to worry about setting the temperature as long as you have the correct color band tip for the solder you're soldering. I will say this soldering job definitely wouldn't win any awards, but hopefully it's functional. Okay. All right, now I have to go attempt to find an appropriate power supply, and I will return. Alright, so I found a suitable power supply for this kit. It comes courtesy of an old Arduino kit. So, without further ado, get this set up. Plug that in. And as you can see, there it is, all booted up. So there's a nice 1 kilohertz, 3.3 volt test point. And we hook the lead up, and we get a nice little square wave. So you want to adjusting the switches changes the waveform. So there it is, working. The next video will be putting this in a nice little acrylic case. Thank you.